wondered how your body learns a new dance move, a perfect golf swing, or even just how to balance? It's all thanks to the fascinating world of motor control and learning. Today, we'll dive deep into the science behind skill acquisition. Here are the 7 key questions. How are motor control and learning determined at a cellular level? Motor control and learning at the cellular level are primarily governed by synaptic plasticity, which is the ability of neural connections to strengthen or weaken based on experience and activity. Neurons in the motor cortex, basal ganglia, and cerebellum communicate through neurotransmitters, forming complex circuits that refine movements. Long-term potentiation and long-term depression help in learning new motor skills by enforcing frequently used neural pathways while weakening less used ones. Additionally, myelination of axons improves signal transmission speed, further enhancing motor learning and control. What structure contribute to perception, and how does perception contribute to the learning and control of motor skills? Perception relies on multiple brain structure, including the sensory cortex, visual cortex, and proprioceptive system. The cerebellum and basal ganglia play a role in integrating sensory feedback for smooth movement execution. Perception is crucial for motor learning because it allows individuals to adjust their actions based on real-time feedback. For instance, when learning to play a sport, visual, auditory, and tactile inputs help refine coordination and accuracy. Without accurate perception, motor skills would be imprecise and difficult to control. What is kinesthesis? Kinesthesis, also known as proprioception, is the body's ability to sense position, movement, and force without relying on vision. It is facilitated by proprioceptors located in muscles, tendons, and joints, which send continuous feedback to the brain about position and movement. This sense enables individuals to perform actions like walking, typing, or balancing without the need to make movements. Kinesthetic awareness is essential for coordinated movement and motor learning, as it helps individuals adjust and refine their movements automatically. What two visual systems control movements, and how do they differ? The two visual systems that control movement are the dorsal stream and the ventral stream. The dorsal stream, often called aware pathway, processes spatial awareness and motion, helping with actions such as reaching, catching, or navigating through an environment. It operates quickly and unconsciously. The ventral stream, or the water pathway, is responsible for object recognition and detailed processing, helping identify shapes, colors, and identities. While the dorsal stream is crucial for coordination, the ventral stream helps in recognizing objects before interacting with them. What are the major structures of the brain contributing to motor learning and control? Several brain structures contribute to motor learning and control. The motor cortex initiates and plans voluntary movements. Cerebellum fine-tunes movements by integrating sensory feedback and ensuring precision and balance. The basal ganglia help in movement initiation and habit formation, playing a key role in skill learning. The brainstem coordinates automatic movements, and the spinal cord acts as a pathway for motor signals to reach muscles. These structures work together to refine movement execution, adapt to new motor skills, and maintain control. How does the central nervous system coordinate movements? The central nervous system coordinates movement through a hierarchical control system involving the brain and spinal cord. The motor cortex sends signals to the spinal cord, which then transmits these commands to the muscle via motor neurons. The cerebellum continuously monitors and adjusts movements based on sensory feedback, ensuring fluidity and accuracy. The basal ganglia helps filter and fine-tune motor commands, preventing unnecessary movements. This coordination allows for smooth, purposeful actions and the ability to adapt to changing environments. How are muscular contractions organized and controlled by the central nervous system? Muscular contractions are controlled by motor neurons in the spinal cord, which receive signals from the brain and relay them to muscles via neuromuscular junction. When a motor neuron fires, it releases neurotransmitters like acetylcholine, which bind to muscle fibers, causing them to contract. The strength and duration of contraction are regulated by the rate of nerve impulses and the number of motor units activated. The CNS continuously adjusts muscles contractions based on sensory feedback, ensuring precise and coordinated movements. In summary, motor control and learning are complex processes governed by neural plasticity, sensory perception, and coordinated activity within the central nervous system. Key brain structures, including motor cortex, cerebellum, and the basal ganglia, work together to refine movements, while sensory feedback from visual and kinesthetic systems help adjust and improve motor skills. The CNS plays a crucial role in transmitting signals for muscle contractions, ensuring smooth and precise movement execution. Understanding these mechanisms highlights the intricate relationship between perception, learning, and motor control, which is essential for skill development, rehabilitation, and daily